All right, so in this problem number 3 here, let's take a look at this. It says we're comparing math students who took a CPMP course to traditional class, and then are the means of the scores significantly different. Okay, so we have to write, the first thing we're going to do is write hypotheses, right? So the first thing we would do is define our parameters. So our parameters here are, these are the mu of C is the mean scores from, what is it, the CPMP course? Yeah. And then mu of T is the mean scores from traditional course. Okay, so then we got to write the hypothesis. So the null hypothesis would be that mu of C equals mu of T. And then the question is, are they different? So the alternative would be mu of C does not equal mu of T. Okay, it didn't say that one is higher or one is lower. Okay. So now we got to go through part B, are the assumptions, right? So what does it say here? It doesn't say that the courses were randomly assigned. Well, we can assume that students were randomly assigned. Or we can assume that the students are representative. Either one is fine. If you're not comfortable with the fact that they might have been randomly assigned, you could choose that one. Independence, in this case, we would do that the classes or the samples are independent. So the CPMP course is independent from the traditional course. Okay. And then we got the two samples, so 312 and 265 are both less than 10% of all students. And then we got the normal condition, right? So again, central limit theorem. Remember that we said at least if our n size is at least 40. Well, in this case, both samples are large enough. Due to the central limit theorem. Yeah, we definitely have large enough samples. I mean, that should not be an issue. Okay. So then here is the output from this deal right here, right? And it says, okay, you got a 2-sample t-test, and here's what they tested. Here's the t-statistic. It's negative 6.451 with about 575 degrees of freedom, and your p-value is less than 1. Okay, so what does that mean? It means if the mean scores for the CPMP course and the traditional course were equal, if the null hypothesis was true, then there's less than a 1% chance of seeing the difference that we saw, or larger, due to natural sampling variation. Okay, so basically, if the null hypothesis is true, there's this probability that we would see the difference that we saw, or larger, if in fact this was due to natural sample variation. So what's our conclusion? Our conclusion is since P is less than 0.001, you know, there's going to be very strong evidence. Very strong evidence that mu of C does not equal mu of T. We would reject the null. We would reject the null and accept the alternative hypothesis. So there is very strong evidence that these are not equal. What does this suggest? It suggests that the CPMP students looks to be higher than the traditional. Yeah, and where do we get that from? I'm sorry, it's the other way around. The CPMP is, I don't know. It's actually that the traditional actually did better. The traditional students actually did better because their mean was 38.4 as opposed to the mean of the CPMP students. So there's actually evidence that traditional students actually did better.